All right, let's look at one last example for our class here. Here I have an exponential function. I have e to the 3x plus 2y power. So hopefully you look at this and say, hey, I've got this function here of x and y, 3x plus 2y, inside of this exponential function. When I take the derivative, I'm going to have to use the chain rule. So here, I'm going to go through this relatively quickly. If I want the first order partial derivative, and actually here, we'll do the first one. We'll draw it all out. So we should start by finding f sub y, but before we do that, we may want to rewrite that. We may want to say, okay, here is u is just the inside function, which would be 3x plus 2y. First, I want the partial with respect to y, so u sub y. In this case, would just be 2. So f, my original function, I can think about as e to the u. So if I want f sub y, this is really equal to e to the u times u sub y. And if you want to, I would go ahead and take u sub y and plug that back in. You can take u and plug that in as well. I don't think that's as necessary, and I'll explain why in just a second. So right now I have the first order partial derivative. This is equal to e to the 3x plus 2y times u sub y is 2. Maybe I'll rewrite that as 2e to the 3x plus 2y power. So here's my first order partial derivative. I want the second order partial derivative though. And here I see, okay, again I have 3x plus 2y. That's a function of both x and y inside of the exponential function. It's another chain rule. U is actually not going to change though. U is actually still 3x plus 2y. U sub x here in this case, because now I want the partial with respect to x, is just 3. So if you need to, take a moment here and say, okay, f sub y, this is really equal to 2e to the u. So derivative of y, f sub yx, that's going to be 2e to the u times u sub x. So this is 2e to the 3x plus 2y times 3, or 6e to the 3x plus 2y power. So here's that second order partial derivative that I was looking for. This is f sub yx of xy. Holy moly. Let's look at one last second order partial derivative. And just to write our function here one more time, f of xy, we said that was e to the 3x plus 2y power. So here I want, first of all, the first order partial derivative with respect to x this time. So here I'm going to go a little bit quicker. So first I would say, okay, multiply by the power, right? I'm looking at this as e to the u. I know that the derivative of e to the u is really u prime times e to the u. If you want to use that shortcut, say the derivative of my power with respect to x, that's going to be 3e to the u, the power stays the same, so 3x plus 2y power. And then if I want to take the partial with respect to y now, f sub xy, x comma y, this part's going to stay almost identical, 3e to the 3x plus 2y power, but I need to multiply by that u prime, which in this case, I'm taking the partial derivative with respect to y. So the derivative of 3x plus 2y with respect to y, that's going to be 2. So 2 times 3, hey, there I have 6e to the 3x plus 2y power. I see once again, hey, that these two matchup. That's awfully nice. Again, I won't say that will happen every single time, but it will happen the majority of the time. So I guess that's it. That's the end of business calculus. So at this point, I'll just say the end. I hope you've learned a little bit about calculus and a lot about yourselves along the way. I wish you all the best of luck in your future studies. If you have questions about this section or anything else going into the final exam, please feel free to email me. I'll do my best to get back to you as soon as I possibly can. But that's all I've got. Hope you guys take care out there.